This is a step-down converter circuit. When the switch transistor is closed and conducting, the voltage across the inductor is positive on the left and negative on the right, causing the output voltage to be lower than the input voltage. At this time, the freewheeling diode is cut off, and the current from the input power source flows through the inductor, storing energy in the inductor. The current flowing through the inductor not only supplies power to the load, but also charges the filter capacitor. When the switch transistor is turned off, the input power source no longer supplies power to the inductor. To maintain continuous current and prevent sudden changes, the inductor will reverse its voltage direction, forming a current loop, and the freewheeling diode will conduct. When the switch transistor is off, the inductor and capacitor together discharge to the load. During the discharge process, the current through the inductor gradually decreases. If the inductor current drops to 0 amps, the capacitor will completely supply the load. In this case, the voltage across the capacitor will drop faster. Many people struggle to differentiate between the start capacitor and the run capacitor of our motor. If your motor only has one capacitor, it is definitely the start capacitor, which is denoted by the letter CD. If your motor has two capacitors, those starting with CBB are run capacitors, while those starting with CD are start capacitors. Another method of distinguishing them is by comparing the capacitors on the same motor. The one with a larger capacitance is the start capacitor, while the one with a smaller capacitance is the run capacitor. Typically, the capacitance of the start capacitor is 5 to 7 times that of the run capacitor.